Section 1. A mystery before the pharaohs. Sometimes, a story begins not with a word, but with a whisper from the earth. We think we know the timeline of human genius. We point to the Great Pyramids as a dawn of engineering, a moment we learned to build for eternity. But what if that was not the beginning? What if, long before the first pharaoh dreamed of a sky tomb, another people were already shaping stone and metal into something we only now begin to understand? A discovery, far from familiar sands, asks us to hear a much older whisper. It speaks of a technology that should not exist from a time we thought we knew. This is not fantasy. It is science. Patient work under a relentless sun. Real objects held in human hands, challenging our comfortable past. These are no monuments, small, intricate, puzzling. Pieces of a machine, a device with moving parts, from a civilization history forgot. Innovation was never a single line. It was a branching river. Streams of knowledge flowed, and sometimes vanished, long before the empires in our textbooks. If complex mechanisms existed thousands of years earlier, what else did they know? Section 2. The trail in the sand. It began not with a scroll, but with satellite images. Archaeologists, geologists, engineers, following digital breadcrumbs into emptiness. Faint discolorations, almost imperceptible patterns, signs of something man-made below. They probed with ground-penetrating radar. The picture beneath their feet was not a tomb or temple, but a compact chamber-like structure. Following these digital ghosts, they began to excavate, layer by layer, documenting every stone, shard, and grain. Let us look closer at what the earth gave back. A heavy, curved stone base, like a cradle, with perfectly smooth cylindrical boreholes. A straight, uniform rod of a dark, heavy metal, testament to skilled metalworking. And the most surprising, small, flat stone discs carved with interlocking teeth. They were, unmistakably, gears. As pieces came together, the logic of a mechanism emerged. Polished bores where the rod rotated. Microscopic friction on teeth, evidence for movement. A panel with finely etched lines, perhaps a guide or indicator. A disarticulated skeleton of a machine. Some bones missing, the power source unknown. Chemical analysis revealed a deliberate copper alloy, harder, more durable than simple copper. The stone, diorite, notoriously hard. Cutting precise teeth demanded immense skill and serious tools, yet the parts fit with precision. Smooth rotation, clean meshing, a deep grasp of mechanics, a level of engineering once dated to millennia later. Before moving a single piece, the chamber was captured in three-dimensional detail. Context preserved forever. Engineers built virtual models, testing how parts fitted and moved. Replicas proved viability, a simple turn of the rod driving stone gears in steady rhythm. A falling weight could power it, a slow, consistent energy, like a grandfather clock. No mystery power required, or flowing water. The genius lay in design, not the drive. From scan to simulation to replica, the echoes of a forgotten machine grew louder, a whisper now made visible by modern tools. When we think of ancient technology, we see ramps, ropes, levers, the triumph of scale. Egypt mastered monumental engineering, organizing immense labor to move mountains. But this device speaks to another path. Precision, toothed gears linking motion in predictable ways. Perfect bores in diorite, specialized alloyed metal, sophisticated design thinking. No single ladder of progress, multiple paths of innovation, driven by different needs. One culture perfects moving mass, another explores delicate mechanisms. Ingenuity was diverse and widespread, not owned by a few great centers. Pockets of independent innovation may have flickered, then disappeared, bright spots in the deep past. History credits the Greeks with the first sophisticated mechanisms, like Antikythera. This would push those origins back by thousands of years. It implies deep mechanical understanding long before Plato, Rome, even the first Egyptian hieroglyphs. not just surviving, experimenting, designing, engineering. A controlled motion device could grind, lift, or track the heavens. A calendar for life itself. It might even guide carving or weaving, art through mechanism. The world teemed with creativity, ideas sparking in many places. History is not only empires and monuments, it is also the quiet innovators buried by time. A single find will not rewrite history overnight, but it adds an unexpected first chapter, revealing a far older, more complex story of technology. We must be ready to find genius in unexpected places. Evidence that our drive to shape the world is very, very old. In science, extraordinary claims require extraordinary evidence. The team knows this. The artifacts compel but demand caution. A machine interpretation best fits the data, not yet a proven fact. Pieces are missing. Without a full device or power system, function remains an educated hypothesis. Could it be ritual or a game? Mechanical wear makes that unlikely. There are limits: corrosion, fractures, incomplete motion paths, an isolated find, a single data point until others appear. Avoid sensationalism. Lost super-civilizations, extraterrestrials. The evidence points to human ingenuity. Stone, copper alloy, universal mechanics. Transparency and peer review are essential. The team is publishing in reputable journals. Radiocarbon dates, metallurgical analysis, three-dimensional scans, all to be scrutinized by other experts. Debate and verification will refine or revise the claim. That is how we move from possibility to fact. A discovery like this is not an end, but a beginning. The team will expand the search, hoping for more pieces, or even another mechanism. Collections will be reread with new eyes. Ritual unknowns may reveal mechanical lives. Imaging peering deeper, isotopes tracing ore to mines, microscopic tool marks naming ancient tools. We stand at a crossroads in our story of the past. We found one extraordinary glimpse of ancient technology,